So we will discuss the rational class definition and implementation in some greater details. I have added a couple of things to the rational class definition. This is different from the rational class defined in Kuhn's book. You will see a lot of similarities and you will also see differences. So please note down the definitions and the implementation details of the rational class as I am doing it here, and compare that with the rational class definition and implementation given in the Kuhn's book. This is to tell you that there is no single unique way in which you can define a class, although objects of the class are expected to have exactly similar or identical behavior. The implementation could differ. First, let me complete the important announcements right now. Submissions were due for your stage 1 report. How many of you have submitted reports? That means others have not submitted. Okay, just for your information, I am reducing the weightage given to the first stage report because those few reports which have been submitted, I went through some of them. The diary details are not included, for example. Which member of the team has done how much work is not clear at all from the reports. You are expected to write a report describing all the work that you have done. In any case, I am extending the date of submission of stage 1 report. A link has already been set up where you can upload a tar file. That tar file, to begin with, may contain just a single text file which you can write using gedit and upload. That text file should describe the problem that you have chosen, a brief description of the functionality that you propose to implement, roll numbers and names of the members of the team, the name of the coordinator, and if any work allocation that you have done. Some of you would have done some sample coding on a test basis. If you have done that, you are most welcome to include that. All the work that you have done in the last 2.5 weeks should be included in that report so that it reflects the quantum and quality of efforts that you have put in stage 1. I will be personally correcting the stage 1 reports, although the TAs will also have a look at it. The submission date is this Sunday midnight. I am aware that many of you would be probably going home for Diwali holidays, although Diwali is not supposed to start till Wednesday. But that's okay. I have already announced that I won't be conducting a lecture on Tuesday. But this is for those few of you who are still on the campus and would like to benefit from the discussion on the solutions to the makeup mid-sem paper are welcome to attend the special lecture which will be held on Saturday, that is tomorrow, from 2 o'clock. I will call it a tutorial discussion This class may go on for about 1.5 hours to 2 hours, where I will discuss the alternate solutions to makeup test problems. In any case, the tutorial discussion will be recorded and the audio visual will be put up on the link as well as the lecture will be put up on the Moodle. So those of you who miss it and would like to look at it can look at it later. But please note, stage 1 submission deadline is Sunday midnight. A single tar file should be uploaded. You already know how to create tar files. The tar file can very well contain a text file that you have. if you have created some code which exists in different directories for different members of the team, you could put all of them under a project directory, and all subdirectories and everything you can put in a single tar file and submit it. But minimally what I would expect is at least a text document which will say, and I repeat, the statement of the problem, some description of what the problem functionality that you propose to offer, any analysis that you have done, any distribution of work that you have done amongst the team members, and any sample test programs that you could have written towards that. Additionally, an approximate estimate of the amount of minutes or hours that are spent by each individual member of the team. So what you could do is you could give the list of all team members, roll number, name, and in bracket you can write approximate minutes of time that that particular member has spent on the project. And this should be uploaded by only one person of the team, typically the coordinator of the team. Is that clear? Sunday midnight is a hard deadline. After that, although I have asked my staff to keep the link open, but very heavy damage will happen to the marks that you will score if any submission is made after Sunday midnight. You need not wait till Sunday midnight. You could finish the submission today itself. Those of you who have already submitted might want to relook at their own report, and they have a chance to resubmit a tar file now at the link that has been given. This tar file will be looked at by your TA and by me. Okay. With this, we go ahead with the discussion on the rational operations. We had briefly discussed this main program which operates upon rational numbers. As I said, when you try to design a class and try to define member functions of the class, you would like to have a clear idea of what kind of interface you want between your programs and the member functions of the class. It is not uncommon, therefore, to imagine the functionality in your mind and try writing some kind of a main program first. This need not be the final main program that you will write. This is the draft. Of course, what I am presenting is a program which actually works correctly. It has been tested, but it is possible for you to write just a draft main program. The primary objective here is to identify the interfaces between your program and the class member functions. Int G is just an integer variable. At this juncture, you do not know what it is for. I will explain that. But you will notice that I am defining rational C1, rational C2, 3, 4, C3, 1, 3, C4, C5. Notice that I am therefore implying that the class name is rational, which defines a rational type object, and that I am defining various objects. I am also defining some initial values for those objects. Obviously, there should be constructors in my definition which will permit such initial values to be allocated. We of course note that our rational numbers are always in the form of A and B, where A is the numerator and B is the denominator. Any name can be given. Next, I am using a function display. I am displaying objects C1, C2 and C3. Clearly a display function is required, and hopefully it's a member function of the class, or it's a function which I have written myself along with this program sum. If this were to be a member function of the class, would it be written like this? So why did you not object when I said that it could be either a member function or a function written by me? Please remember, a member function of the class is invoked only by an object of the class. It cannot be invoked as a standalone function by you and me. This particular example or this particular expression, C4.radd C2, C3 is clearly an example of a member function, because C4 is an object of the rational class, and therefore whenever I write C4 dot a name, that name must be a member function in the class. you can see clearly that the intention here is to add C2 and C3, which are rational numbers. This is the simple output statement which shows the result of addition, and I am saying display C4. I clearly expect that C4, which has been hopefully modified to now contain result of C2 plus C3, would be displayed here. So this should tell you the kind of functionality that I should have in the display function. Obviously, display function is not part of the member functions of the object. I have written one more function here, C5 multiply, R multiply, just like R add. So R multiply, what is it expected to do? Multiply two numbers, two rational numbers C2 and C3, and it should print the result of the multiplication. Multiplication, or in fact addition, any operation on two rationals might result in a rational value of the form A by B, which is not in its minimal form. So A and B might have common factors. Is that how you represent rationals? No. Rationals are always represented such that the numerator and denominator do not have a common factor. Let us see, G represents the common factor amongst all of them. Now, either I can extract the individual data elements of the class object C1 or C2 or C3, say A and B, and myself do some manipulation here, or I can add a new function to the class which will reduce the given rational number A by B to the minimal form. This is the path I have taken in this example. I am saying G is equal to C5 dot reduce. I am assuming that C5 may result in a rational number where the numerator and denominator are not relatively prime. They have a common factor. In which case, I would like to reduce that and also generally know what was the common factor. Clearly, this member function is written such that it will take two rationals, it will take one rational, which is C5, reduce A by B to the minimal form, in the process discover what was the highest common factor and will return that. And that is why this function must have a return value of the type integer, because the return factor is an integer. So it operates upon a rational and returns an integer. You can see that if G is not equal to 1, that means there was a common factor, so rational is not minimal, HCF is G, and then I display again. By this time, I would expect C5 to have been reduced to the minimal. So this in general is my attempt to imagine what kind of interfaces I would need between my main program and the objects of a class. Okay. Having done that, I can now proceed to define my class and proceed to define the implementation of the class. But first, you remember we had a display function. So a display function is required to be used because that is supposed to display certain things. Notice that this display function is a void. This is a prototype, void display rational. I don't need to put an object name here in the prototype, just the type is sufficient. What it means is that the function display which I am writing will take one rational object as a parameter. And this particular line must appear before my main program because it is a function prototype definition. I could of course put the entire function definition ahead of my main program, but as I said, very often such detailed description of the function could occur in a .h file somewhere. Minimally what I require is to include this, which in turn could again appear in another .h file. But a prototype definition must appear before the main program. The function itself is described here. It displays a rational number in two forms, either as A by B or as an equivalent floating point number. So I am defining float x int A comma B. Now here I come across another interface requirement. I want to find out what are the two data elements of a rational object. What is the numerator, what is the denominator. But those values are not accessible to me directly in my main program. Please remember that data members are private to an object class. So to every object, the data members are private. Consequently, I must have a function which is a public function of that class itself, which I can use, which in turn can look at those private data member functions and can give those values back to me. That is what is written here when I say C.R components. So rational value has components A and B, and this function is clearly an additional interface requirement for me to go to an object and ask it, please tell me what are your component values. So I can invoke it on any component, on any rational object C, which is a parameter here. C.R components A comma B, okay, is supposed to give me back A and B. Please note that these A and B, although the name may appear same as the one used in the class definition, they have nothing to do with those A and B. These A and B are integer variables in my program. I could very well have written A1, B1 or P1, P2 or whatever. These are two integer numbers. All that it means is that I am trying to get R components from this function. And then I will print A and B, and I will also print equivalent float value. Equipped with this understanding of the interface definitions, we now proceed to define and then implement the rational class. We start with the keyword class rational, and then say this is a class to handle rational numbers, objects are of the type A by B. You can write many more things, authored by so and so on this date, okay, part of the project for CS101, whatever, all kinds of inline comments that you would like to write in your programs could be written here, should be written here in fact. Earlier we had discussed a version of this rational class implementation. I am calling it version V1 because in this V1 I am saying a rational is reduced to a minimal representation such that A and B are mutually prime. Now I have private data members int A and int B as you have already seen. I have public member functions. First the constructors. There is a default constructor rational and a parameterized constructor rational int comma int. There are functions for other operations. So void R add, it takes two rational numbers and adds them. Void R multiply, it takes two rational numbers, multiply them and sets the calling object to that value. Please note that these are all member functions which are invoked by an object. That is why I say something like C5 R add C1 comma C2. So C1 comma C2 are added where the C5 object which invokes this function actually gets the resultant additional value. Same thing about multiply. And then as I said, void R components. Notice that here I am saying int and int and. So far we have seen that whenever I have a pointer in the formal parameter of the function, the corresponding value should also be a pointer. C++ does not require that. When you mention, say, x comma y in the actual parameters and the formal parameters are int and, then automatically the pointer is, it is sent by reference. So that means that whenever you modify the formal parameters inside this function, the corresponding actual parameters will also stand modified. Okay. So far we had seen the reference, passing by reference was by using pointers. Okay. But this is a passing by reference mechanism which is valid in C++. Last but not the least is our reduce function. The reduce function does not take any parameter y because it works on the object which invokes it. So if I say C4.reduce, it will take components of C4, A and B, reduce them to a minimal form. But it is expected to return something. Do you remember what it was supposed to return? The highest common factor. And that is why the return type is mentioned as int. So this completes the definition of the class. Okay. We have not yet defined the implementation. We have just defined the interface. So once again to repeat, a class has two aspects to be defined. First is the interface definition, which will also, apart from the public functions, it will also include the definition of private data members and any other functions that you may have, such as protected functions, etc., which we shall see later. All the constructors, destructors, whatever, everything should be included in the definition. But once you define them, you have to elaborate on what those public functions do. And that elaboration comes in what I call the definition of implementation. This should be following immediately the class definition. So you write the class definition and immediately continue with the definition of the member function. So here I have the beginning of the definition of the member functions, rational : rational. This is a constructor, obviously, it's a default constructor. As we saw yesterday, day before yesterday, A is equal to 0, B is equal to 1 is the default value that I am assigning. You could assign any default value of your choice. This is a parameterized constructor. It will expect two integer parameters, x and y. X will be assigned to the numerator, y will be assigned to the denominator, as you can see. There is one extra care that is being taken here. If somebody specifies denominator as 0, will it be a valid rational number? No. So you would like to take care of it. If by mistake somebody defines the value to be 0, I would like to say if y is 0, b is set to 1. Otherwise, b is set to y. So this is a default definition which I am providing. Here is the rational addition. It expects two rational objects, R1 and R2, and it calculates the addition value for individual data members of the object which caused this addition function as A equal to this and B equal to this. Obviously, this is the way you will add A by B and C by D, for example. Here is a multiply function which is very similarly written to the add function. It will expect two rational objects as parameters and will calculate the result for the invoking object. This is the addition. If I want to get the components, this is the components. Please remember what I said last time. I am trying to peep into the individual data members of the object. I want to know them, and that is why I am doing it. However, it is not considered a healthy practice. Generally, you will not return the values of A and B, which are the data member elements of the class. What you will say is, you tell me what you want to do with these values, and I will do it. If you want to display those values, let me do it as the class. I won't let you touch those things. So you can specify, output these components in this form, or write these components in this file. Let me do everything that is related to those components. But please don't try to peep into those components because they are private data members. That is how you would like to guard those things. In this particular implementation, I have violated that principle. I have violated that principle because supposedly I am trying to mimic all of you. When you try to first learn what classes are and try to implement classes, it is quite likely that since you will need to display those values, you might think of writing such a. Nothing is wrong, by the way, in this. This is perfectly valid C++ program. It works correctly. Okay. It is just that it is not considered a very good professional practice to expose private data members to external. However, in this case, I have a function called R components. It takes a pointer to M and pointer to N and returns two integer components of a rational A and B. Here is the implementation of rational. Reduce. You remember what I said? A by B need not be in minimal form. So I define AN and BN. I define a max factor. And G is the one which is to be returned. I start with G equal to 1. I start with AN equal to A and BN equal to B. Now, I have to keep on dividing AN and BN by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all integer numbers. Okay. Somewhere a number will divide both of them. Whenever that number divides both of them, I should capture that into my factor and of course reduce A and B after that division. Otherwise, some number which is divisible by 4 is also divisible by 2 and you will count 2 and 4 as independent factors, which is not correct. So you divide by something, divide by something, divide by something and reduce it and you will get, this is the iteration that I have run. Notice that I am saying max factor equal to A greater than B question mark, B colon A. So if A is larger than B, I set max factor as B. If A is smaller than B, I set max factor as A. Obviously, the smaller of the two will be the largest common factor, if at all. Okay. I run an iteration for I equal to 2 to max factor and I keep finding out, please note, I have captured the member elements A and B into AN and BN. So far I do not want to change A and B direct. I am just checking. So I am changing AN and BN and if everything is satisfactory, I will assign those values to AN. The program then continues to check whether AN modulo I is 0 and BN modulo I is 0. If I is a common factor, then I take that A common factor out, I multiply G by I. Let's say 2 is a common factor. I started with G equal to 1. So G will now become 2 and the division by 2 for each of these numbers will reduce AN and BN to the next value. Suppose 3 is another common factor, it will again get divided, 3 will get factored into G and so on. Finally, when I come out, I will assign AN to A, BN to B and return the value of G. Now I want you to pick holes in this implementation. Yes. What if it is 4 by 8? So what will happen? Execute the algorithm. So what will be max factor? Max factor will be smaller of the two, which is 4. This iteration runs for I equal to 2. So let's say I is equal to 2. At I equal to 2, what will happen? Both AN and BN are divisible by 2. So AN will now reduce to 2, BN will now reduce to 4. And G will become 2 because 2 has been a common factor. Now I becomes equal to 3. Is 2 divisible by 3? Is 4 divisible by 3? No. So this remains 2, 4, this remains 2. Then I becomes equal to 4. That's the last iteration. Is 2 divisible by 4? No. So this remains 2, this remains 4, this remains 2. And at the end, this becomes A, this becomes B. Problem. You can see that in a simple issue of finding out the highest common factor, I could do a simple goof up of this kind. As you will see, I have executed this main program once to show the results, and the results look perfectly fine, because it so happens that the particular rational number which results out of some operation and which I reduce and print is actually reduced correctly because it is not of this type. What is peculiarity of this type? There is the same factor which appears many times. So it is not just 4 by 8. You can take anything which is a multiple of 2 to the power n, for example, by something which is also multiple of 2 to the power n. Okay? You will get the first 2 out. Hopefully, if there is a factor of 4, that means you have 8 as a common factor, you will come out correctly. But if you have 2 appearing twice, 3 appearing twice, it will not work. What should be the correction? You get the correct solution? Instead of running the iteration from 2 to max factor, you start from the max factor downwards. That way, you will take out the largest common factor first, and if something remains, that will be at the lower end. Will it always work? Nobody is confidently saying yes. Try to construct a counter example. But the correct thing we are saying now is our iteration should be for I equal to max factor I greater than equal to 2 I minus minus. So this is how I will be able to get. I have one more question to add. 2 things I am leaving behind for you to work on. A, will this always work? So think about it later and find that out. B, is this the most optimal algorithm to find out highest common factor? Anybody who is familiar with a better, more efficient technique of finding out common factors? Should it not be very obvious that I should be dividing, should I be dividing by all the numbers in the range? Okay, I will leave that to you. You can either go to Wikipedia or to any standard book on algorithms, and it will tell you the best algorithm or the fastest or the most efficient algorithm to calculate the highest common factor. We digress a bit, but these are precisely the issues that you should look at. When you are implementing a project, the first thing is to get the functionality right of whatever problem solution you are thinking of. The next, before you finalize your project report, examine each and every implementation. Is it written in the most optimal fashion? Is the program most efficient? Can it be made better? And is it written in an elegant fashion? And finally, is it written such that others can understand what you have written? These are the 3 parameters on which you should examine any program that you run. I would like to discuss operator overloading before I call my friends there. We know standard operators plus, minus, star, slash, modulo operator. We also know comparison operators. Okay. Would it not be nice if I had rational C1, C2, C3, and somewhere in my program I could directly say C3 is equal to C1 plus C2. Would you not like such an implementation? It is natural, it is meaningful, because rational number addition is defined conceptually to be very similar to the addition of 2 integer numbers or 2 floating point numbers. Same thing goes for C3 equal to, say, C1 star C2. Same thing goes for if C1 greater than C2. Do you agree? Comparison between 2 rationals actually is a comparison similar to comparison between 2 integers or 2 floating point numbers. Would you not like to do this? One more thing. Would you not like to say this? You see how easy your programs would become and how logical they would read. Such things are possible in C++. In fact, C++ explicitly provides for you to take normal operators and redefine them to extend their meaning. That is called operator overloading. All the operators can be redefined like that. And now you will note, when I say all operators, what about these symbols? This symbol and this symbol are also operators in C++. They are called extraction and insertion operators. C in greater greater C1 or C in greater greater anything, that greater greater is actually an extraction operator. You will remember that C in represented STD in, reading from standard input. So standard input is a stream of bytes. The bytes are coming as you type them on the keyboard. And those bytes are to be interpreted. Those bytes are to be assumed to mean ASCII values, and you have to interpret chunks of those bytes as an integer number, floating point number, and convert it into internal form. That is what C in does. So C in operates upon STD in stream. And the C in is defined as a stream of type STD in. And it has an extraction operator called greater greater. Similarly, C out is defined as an O stream or an output stream. And less less is defined as an insertion operator. What is C out trying to insert? It takes an integer value or a floating point value, converts it into a nice ASCII string which represents that value, and inserts it into the output stream with blanks in between, whatever you say. So C++ treats these also as operators, and therefore it permits overloading of these operators as well. It has certain caveats, certain rules. For example, a binary operator, meaning an operator which requires two operands, must have two operands even when you overload it. Similarly, a unary operator, if it is used in a unary sense, must have one operand. Common sense caveats. There is a whole lot of description of how operators are to be overloaded. I will just show you how the addition operator is overloaded in this particular case, and then we can expand that or extend that to other things. So first, I need an interface definition. Please note that operator overloading is to be defined as part of member functions of the class only. So after you have described data elements, which are private data members of the object class, then you describe member functions of the class, which do, for example, addition, subtraction, whatever you decided, reduce, other operations, and then you can define extensions to operators. This is the definition that will appear in your main definition of the interface. Rational operator plus. This operator is a keyword. You can't write anything else here. The word operator is the keyword. It's a reserved word. So the operator word tells C++ that I am not defining any new function by a different name. I am actually trying to redefine one of your standard operators. And what is that operator? Without any intervening blank, you write that operator. That operator will usually be one symbol or two symbols. Plus, minus, star, slash, percent, greater, greater, less, less. Whatever you write must be a valid operator in C++, which is extendable. As I said, most operators are extendable, but not necessarily all operators are extendable. It's also an additional matter whether the extension of the meaning of that operator makes sense in the context of the class that you are defining. For example, you have defined an employee class and you have employee IDs. Now, can you add employee 1 plus employee 2? Obviously not, it won't make any sense. Okay. So it would make common sense, it should make semantic sense also in the context of what you are doing. Observe, what are the two parameters? Const rational and R, const rational and S. So there is a rational parameter 1, rational parameter 2. What is extremely important is to remember that there is a left parameter and there is a right parameter, because you are overloading the plus operator. The meaning of this is that the actual invocation, where you normally say C5 dot reduce or C5 dot add, rational add something, C1 comma C2, you won't be saying any such thing, because there is no function name, there is a symbol name, and this symbol when overloaded, still means that it has to be used exactly as it is used in the context of other ordinary mortal variables like int or real. That means if R and S are two rational objects for which I am going to invoke this operator, in my C program, C++ program, I will always write R plus S. That's all. The plus now becomes a function call. But this plus function has two parameters, one physically appearing on the left of it, another physically appearing on the right of it. So this is a very peculiar kind of function call. Semantically, it's a function call. So when the plus operator is seen with two sides, with one rational and another rational, then automatically this overloaded function will be invoked. What is the implementation of that overloaded function? In this particular case, I have an overloaded function, const rational and R, const rational and S. The result of this has to be a rational. So the object which invokes this should have this rational. This particular implementation is faulty, as you will see later. I am deliberately giving you a faulty implementation. I want you to read the Kuhn's book and see the correct implementation that he has given. You can implement it in multiple ways, the overloading of function. Here, it is just an idea for you to get how overloading can be defined and how overloading can be implemented. So just as this one will come in the definition and this one will come in the implementation. So here I am saying rational operator plus const rational and R, const rational and S. This returns rational. So R1 plus, say R plus S is supposed to return a rational number. So I am defining a rational number as result, rational object as result. Now once I have result, then result has A and B components. I am setting A component of result as this and B component of result as this. Now I say return result. So this result, which is a rational number, will be returned. The usage therefore of this kind of operation will simply be in my main program somewhere. I will have to say C5 is equal to C1 plus. So when I say C1 plus C2, the compiler recognizes that I have a plus symbol on either side of it are two rational numbers. It will then examine whether I have a overloaded plus defined in that class. If I don't have overloaded plus defined, it will give an error. But if I have it defined, it will invoke that definition. With that definition, the parameters will go to this function. The first value C1. Now, please note, when I say first value and second value, it in the context of plus symbol means the value appearing to its left and value appearing to its right. And these two will go to these two parameters. Using this, it will calculate this. The result which is returned will replace C1 plus C2, as any computational result does for a sub-expression. Suppose I had an integer value m. Would it be correct to say m plus C1? Will this be a correct statement? Many people are silent. You're not convinced. So somebody thinks that there may be some sense. Okay, how many of you think that it could still be interpreted correctly? Nobody. Then only a few people said no. Why others are not confident? Of course it is incorrect. It is incorrect for two reasons. Number one, it does not make any semantic sense to us. Okay. Please note that if C5 is 3 by 2 and if M is 5, then 5 plus 3 by 2 has a meaning in mathematical sense. But in a programming sense, it has no meaning, because the plus operator which has been extended in its definition, the extended definition applies only when you are trying to use it for adding two rational numbers, not otherwise. If you want to operate upon M, you will have to form a rational number using M as numerator and 1 as denominator. And then, only then, you can use the resulting rational number for adding using this overloaded operator. Is that clear? Okay, fine. Okay, with this we'll stop.